Hi and welcome to this fifth stream here at Numa TV. Today we're going to cover some interesting aspects of iOS development. So first of all, what we are going to do is having a look at the ModelViewController design paradigm or design pattern that is very common in iOS development. The next thing we're going to do is creating an application that is based on this ModelViewController design pattern, which I'm going to show you in a second. So let me give you a quick look at what we are going to create before we get started. So here we are. This is a simple converter which converts a temperature in degrees Celsius in degrees Fahrenheit. So if I select using this picker control, if I select about, let's see, 30 degrees Celsius, this converts to about 86 degrees Fahrenheit. And this is a very simple application, but we can cover a lot of interesting stuff that is related to iOS development, especially delegation, for example. But before we get started, let's have a look at the ModelViewController design pattern, which is very important in iOS development. So the ModelViewController design pattern is essential for iOS applications. They employ this. It's one of these concepts that help you organize your code to create apps that are well maintained and also well designed. So what we're going to do here is we're imagining that we're having a game like Rockets and Planets. And with this game, what we have and what you see is one rocket and some planets. But the question is, how do we imagine that in code? What do we make of the real-world elements in our application? Well, first of all, if we have a look at the rocket and the planets, they do have certain attributes and behaviors. And you already know this concept of attributes and behaviors from the concept of object-oriented programming. So how would you describe a rocket and what can it do? And how would you describe a planet and what does it do? And if we have a look at this list of attributes and behaviors, this actually covers pretty much of what we need to define a rocket and a planet. Like the rocket needs a direction, a velocity, a color, and a location. And it may also be able to fire lasers, but it will definitely, or it should definitely, be able to accelerate or decelerate. And the planet, as you can see, there are some other attributes that covers what the planet does, like rotating or implode or explode, and it does have a color or a radius as a property. So what we now have to think about is what users see and interact with. So we do not really see a real rocket or real planet, but a representation of a rocket and a planet. We don't really touch the rocket. We touch the image of the rocket. And the person or user can interact with the app through the view, such as tapping or swiping on what is visible. So this is what our view actually is. And this is one of the terms we're using in the ModelViewController design pattern. So what about the controller? Well, the controller orchestrates the view events and model changes. So if you have a look at this diagram, you see that the user swipes on a rocket on the left, which is kind of a user input. And by that, we're saying, hey, the user swiped on the rocket, and then the controller handles that event. And then we have an output, and the controller tells the rocket, hey, rocket, change your position. And the rocket appears to have moved. So this is actually the controller. So the last term, which is the model, let's have a look at that in detail. And this is often a class or a struct in Swift code. So as you can see, a rocket is defined by its attributes and behaviors. And as you already know from object-oriented programming, we define model attributes as properties and behaviors as methods, all within a class definition or a struct definition. So let's have a closer look at the view again. And what is the view actually? And it is the user interface of the app, what the user sees on the screen and interacts with, like buttons, text fields, or pictures of rockets or planets. So the controller, again, is also nothing else but a Swift class that is connected to the model and the view. And it's just code. And in iOS, a controller is a Swift class that typically extends, for example, UIViewController or TableViewController or whatever. And it is, again, designed to orchestrate communication between the view and the model. So let's have a look at a more complex diagram, again, of this design pattern for extensible and reusable code. So when we have a look at the view, which captures the events from the user, or displays the interface, it gives or it reads a user action, and the controller then receives that event from the view. And what it does is either update the view or also update the model and prepares, for example, items for the view. And as you can see, there are no arrows directly between the view and the model. The model code should only be about the model, never about the interface. And the view code should only be about the about representing the interface and the capturing events. And the controller is where actually all the action is. But that doesn't necessarily mean that this is tons of code. But we're going to have a look at that later. So first of all, this was a short presentation that covers kind of a bit of the ModelViewController design pattern. And what we're going to do now is having a look at Xcode and see how we can actually implement this design pattern in the real world or with an application. So I've already created an Xcode project. I call it a converter, and I've already opened up the main storyboard. And before I continue creating our user interface elements, I'm going to bring up my right sidebar here and change the size of my view controller from this inferred size to, let's say, a 4.7-inch screen, which resembles kind of the screen of the iPhone 6s or 6. And then let's bring up some user interface elements. And first of all, we need a label that displays the temperature for us. So I'm centering that label somewhere here. And let's just enter temperature in degrees Fahrenheit right here. And let's also increase the size a little. So I can also change the font actually. So when I click on this little arrow here, I could, for example, say that I want this to be a custom font. And this is actually, again, something that you won't be able to see in the stream. But as I said, this is a custom font. You get this selection when you click on this little arrow. And what I want to do is maybe selecting Helvetica Neue here with a thin style and increase the font size a little bit, like so. And then I'm going to position this again in the center, and we're going to add some constraints. So I'm pressing Control on my keyboard and drag a line right to the center from my label here. And what I want to select is center horizontally in container and vertical spacing to top layout guide. And to make both adjustments at once, I hold the Shift key on my keyboard and select also the second option. And then I press Enter, and I have the constraints set. But as you can see, there are still some orange lines in addition to the blue lines. And you remember, we always need blue lines for auto layout to be satisfied. And we also see this little icon here in the top left corner, which is a circle with an arrow in it, and it's yellow. So this tells us there are misplaced views. And this is actually because I haven't resized my label correctly. So if I make this a little bigger, then I get this exclamation mark here, or this triangle. And I click it, and again, this is something you won't be able to see in the stream, but there is one option that is called update frames, or I can update the constraints, for example. And I actually want to update the frames, so I just keep the selection active of update frames and click the fix misplacement button. And this automatically gives me a nice looking blue view with all the lines in blue as we want it. And as you've already seen, we have used a picker view, which is quite common in iOS when we select something like a temperature or a date. So I type in picker in my object library, and as you can see, there is even a date picker already created for us, but we don't want to use dates here. We want to use a ordinary picker view, and I simply place it here at the bottom of my screen. And then I have to add some constraints again. So what I do is I press Control on the keyboard, click on my on my view here, on my picker view, and drag it to my view. And then I select, again, with the Shift key press, the options leading space, trailing space to container margin, and vertical spacing to bottom layout guide. And then I press Enter on the keyboard. And as you can see now, again, I have some blue lines and a little bit of orange. So again, I click on the circle here, I get some misplaced views, and I simply select it and automatically let auto layout fix the issues here. And we're completely done. So now, with the user interface complete, we could run the app already in the simulator, but it wouldn't do a lot. So now let's think about what we have. We just created a user interface, which is part of the view. What we also need to do now is creating a model for our application. And we are going to have a temperature range. So all the temperatures, and you must imagine that we have temperatures in the range from, let's say, minus 100 degrees Celsius to about 100 degrees Celsius that we would like to be able to convert. And this is data that we need to provide in a way. So in some cases, you're going to have a database in the background, which you need to provide a model for. Or you will have some files, or you have data on the internet that you need to download and that you need to create a model for. And in our case, we simply have a temperature range, which is the model that we need to use. And we also need to connect this model as a data source for our picker view. And this is going to be very interesting. So let's select our viewcontroller.swift file and press Command N on the keyboard. And what I want to create is a new cocoatouch class. And click Next. And I want this to be a subclass of NSObject. And I think you can see that in the stream, but that doesn't matter. I'm simply calling it temperature range, and I make it a subclass of NSObject. This is a very, very basic class, NSObject. It doesn't do a lot. But once I created it, you see that there we have the class temperature range, we have the colon, and we extend our temperature range with the superclass NSObject. And what we also do is we adopt a special protocol, which is called UIPickerViewDatasource. So I'm typing in UIPickerViewDatasource. And the UIPickerViewDatasource protocol must be adopted by an object that mediates between a UIPickerView object and your application's data model. So this is just a correct place to look for that. And if you have wondered about why there is an NS and here is a UI at the beginning of these class names, the NS is actually an artifact of old Next Step times. When Steve Jobs left Apple and created the company Next Step, they actually had an operating system which was later integrated into OS X. And since they use the Next Step prefix for their classes, we have today still the NS objects, like an NS index path or NS object in that case. But this NS prefix is going to be kicked out with the release of the new Xcode later this year in September. And the UI is actually the prefix for the UIKit, but that's just a nice to know fact in case you have wondered. All right, so let's now create the data that we really need. And as you remember, we want to be able to convert temperatures in the range from minus 100 to plus 100 degrees. So let's create a constant that we're going to call values and assign a range to it. And actually what we need is an array of temperatures or an array of numbers. And there are several ways to do that, for example, with a for-in loop. But we've also learned about a cool function in Swift that is called map. And what I can do here is I'm adding some parentheses here, and I'm adding the range, which is minus 100 to 100. And then I can simply call a map function on this specific range. And with $0, I have one argument here that I'm going to return, and the map function always returns an array. So now this map function creates for us an array of about 200 elements with numbers in the range from minus 100 to plus 100. And that is actually what we have for our data model. This is all the data we need. All right, so let's continue. Because we have adopted this data source protocol, as it is called. And in other programming languages, this is actually called an interface. And we're going to explore these delegation and protocol paradigms in later sessions. But for now, let's keep in mind that sometimes when using protocols, there are requirements. And because of these requirements, we have an error displayed right here. And if you can't see it in the stream, I'm going to read this error to you. Type temperature range does not conform to protocol UIPickerViewDatasource. And this means that we have to implement some functions or methods. And one of them is called number of components. And number of components is the number of, let's say, columns that we want to have in our picker view. And actually, we only want one. So we simply return one. And as you can see here, this is also the return type that is expected from us. We have to return an integer. All right. So then the next thing, you see that we still do not conform to the protocol UIPickerViewDatasource. So what we need to do is also implement PickerView's number of rows in component. So the number of rows in component is actually the number of values that we have. So what we can do is we have an array here, our values array. And what we can do is we can return values.count. And again, we have a return type of integer here, and we simply return an integer, which is the number of elements saved in our values array. And with that in mind, we have now actually created the model for our application. So we have actually the model. We do have parts of the view, the view controller with all its user interface elements, but we also should think about the unit conversion. So we could place that in the controller, but we could also extend, get it out of the way and make it even more reusable, our code, and create a new class or a struct for that purpose. So again, I'm selecting my temperature range file. I'm creating a new Cocoa class. Again, we could use a subclass of NSObject. It doesn't really matter. And I'm going to call it unit converter. And click next and create that file. And so you can see here, we now have a new file, which is called unit converter. And we could even remove the extension of NSObject right here because we really don't need it. And all we want to do is creating a function that is called degrees to Fahrenheit. And no, not degrees to Fahrenheit, just degrees Fahrenheit. And this is going to return the degrees in Fahrenheit. And the arguments or parameters that we need to specify are the degrees in Celsius and Celsius, which is going to be an integer. And we also want to return an integer. And now I am prepared because I know the formula we need to use to actually make the conversion, which is 1.8 times the degrees in Celsius. So let me just copy that here. And then we need to add 32. Well, this is the conversion formula from degrees Celsius to degrees Fahrenheit. And we want to return that. But obviously, this isn't an integer. We have some floating point operations here, and we need to make some conversions. So first of all, we can't multiply a floating point with a integer. So first of all, let's convert that into a float by simply using the float function here. And we could also now place this whole expression into some parentheses and convert that back to an integer. And as soon as we did that, all our errors should be gone. All right. So now we have a way to calculate the degrees in Fahrenheit, and this is also part, we could say, of our model. And now we have to look at our controller, because now the controller needs to make the connection between the model and the view. And what we're going to do now is, first of all, create a connection between our user interface controller and the temperature range. And to do that, we can even use the interface builder. And I'm going to simply search for something called object here in my library. And this object can be actually anything. And as you can see here, it provides a template for objects and controllers not directly available in Interface Builder. And we can use our temperature range for that. So I'm simply dragging that to the left here in my view controller scene about the storyboard entry point. And then I can select the identity inspector here and change the custom class here to my temperature range. And since the temperature range is the data source for our picker view, we can control click on the picker view and drag it to the temperature range. And then this is something you can see in the stream. What I can do is simply selecting data source from this option. And by that, I have created a data source that is connected to my picker view. And you can see that actually if we have a look at the connection inspector, that now we have a connection from the picker view to our data source object, which is the temperature range. So this was the first step. The second step is that our picker view also needs something called a delegate. And to do that, we can, and you sometimes, especially when providing data and dealing with things like a picker view, a table view controller, or a collection view controller, which we are also going to look in detail in a later session, you always need to think of a delegate and a data source in pairs. So we need also to connect our picker view with the view controller, because as you remember, the controller is responsible for connecting the view with the model. And this time we're going to drag, again with Control key pressed on the keyboard, from the picker view to the view controller and select Delegate. And with that, we can have a look at our picker view. And as you can see now here, we have a data source which is our temperature range, and we have a delegate, which we're going to see in a second what this really is, to our view controller. Now, all we need is are some outlets that we can use in code. So let me collapse that and bring up the assistant editor. And I'm going to select Control on my keyboard and drag to the assistant editor. And now here we have a temperature label. Let me connect that. So here's our temperature label. Also, we are going to have our temperature picker, which I'm also going to connect. And we have our temperature range here, which I'm also going to connect as an outlet, which is our temp range. All right. Now I have all the outlets I need. So let's also close the assistant editor and bring up our view controller that now does the heavy lifting. And I talked about delegates already. And delegates are a way to communicate in kind of an event-driven way. So for example, the picker view provides a so-called delegate method, which is called didSelectRow. So we're going to, by using the delegate, we're notified as soon as the user picked a different row, and we can do adjustments in the user interface then. And to work with this delegate, what we need to do is, again, adopt a specific protocol, which I do by writing a comma behind the UController extension, which is extended to UIViewController. And now I'm going to select not the UIPickerViewDatasource, but the UIPickerView delegate. And this is important because we have connected our view controller with the picker view and told it that the view controller will be the picker view's delegate. And to continue, we also need an instance of our converter, which is going to convert the numbers that we're going to use. Since this is only be available in this class, we can define it as private. And let's call this converter. And this is going to be an instance of our unit converter. And by writing some parentheses here, I'm directly initializing that. All right, so now let's implement some of those important delegate methods. And the first one that we are going to use is PickerView title for row. And title for row means nothing else but what is written in one single row of our picker view. And what we want to be written in there is actually the degrees in the temperatures in degrees Celsius. So let's create a Celsius value, which we get from our date from our temperature range object. So we take the values, which is the property that we have created, and then since this is an array, we can simply accessing it using some brackets. And I'm going to add row here, because as you can see here, we have as an argument or parameter provided from this delegate method is the row that we're currently in. So we can use that to iterate through our array and actually accessing every element that we need. And we still have an error here because we're not returning a string as it is required. So let's correct that and use string interpolation to use our Celsius value and append degrees Celsius. And with that done, the error disappears, and we can continue with the with one of the last methods that we have to implement, which is the PickerViewDidSelectRow delegate method. And this method is always called when the user swipes and has decided for a specific row. And we're going to implement a function here, or we'll call a function here, which is going to be called displayConvertedTemperature for row, but we first need to write that function. So let's make some space here. Write that function, so displayConvertedTemperature temperature for row. And let's give that one argument, which is called row. And what we're going to do is we will get, again, a degrees Celsius value here from our temperature range, again, from the values, and use the row parameter here. And then we will simply use our temperature label and its text property and assign a new string, again, by using string interpolation, and we will call our converter, call degrees Fahrenheit, and give it as an argument the degrees Celsius. And with that, we're done. And all we need to do now is append the degrees Fahrenheit. And with that function created, we can finally use the PickerViewDidSelect and call the displayConvertedTemperature for row, and simply enter our row parameter we received from that delegate method and transfer it down here to displayConvertedTemperature. So with that done, we can give our application a try. I'm going to do that on an iPhone 6s simulator. And let me just quickly switch to the proper screen. So here we go. Here we have the simulator. And now we're seeing a simply kind of our displayed temperature in degrees Fahrenheit, which is minus 100 degrees Celsius. And if I scroll through my picker, and I finish now here at 54 degrees Celsius, we know that this is 129 degrees Fahrenheit. And notice that once we're scrolling through and the picker did not finish scrolling, so let me just go about here, and the moment it stops, our event is actually triggered, and we converted the 8 degrees Celsius to 46 degrees Fahrenheit. And this is because, let me just switch back to Xcode for a second. And this is because this event here, DidSelectRow, happens only if the picker isn't moving anymore. And as soon as this happened, we call our displayConvertedTemperature for row function and really do the conversion right here. And as you've seen now, we have different classes here. So just to make sure to get the ModelViewController design paradigm or design pattern to this example, let's have a look again. We have a unit converter and a temperature range class, which is kind of the model. We have modeled here our values, which start at minus 100 degrees to 100 degrees. And we could have put that into the view controller and did everything right here. But that wouldn't, then our ModelViewController design pattern wouldn't apply to our project. And by doing it the way we did, we have separated the model from the view controller as the design pattern requires. And you might asking now, why should I do that, and what advantages does that have? Well, in smaller projects, it doesn't have that much of an advantage. We could have created that whole application just in the view controller file, and often this is also easier to understand a specific concept of programming, or specific UI element, like the picker view, for instance. But as your projects grow larger, you need to plan how you actually want to implement something. And taking the model view controller design pattern into account and thinking in that way will help you to create code that is more readable, that is better maintainable, and it will also save you a lot of time fixing bugs in the future. So now you have this design pattern in your mind, and you can think in that way. And with that, we're closing the live stream for today and switch to the private session, and we're going to explore how to create applications with the model view controller design pattern in a lot more detail. So thanks for watching, and I'll see you soon.